Hello guys, welcome to my YouTube channel. So we have completed two examples on curve fitting a parabola. So let us move into the curve fitting exponential. So in this we have two normal equations which I have written over here. The equation 1 is summation y equal to an plus b summation x, and the second one is summation xy equal to a summation x plus b summation x square. Please make a note that here we have capital Y, capital X, capital X, capital Y, and capital A, small b. In parabola and straight line curve fitting, we had small x, small y, and small a, small b. But here we have capital Y, capital X. So for that capital Y, we have a formula log to the base 10 y. We can take log to the base 10 or else e. In some textbooks it is referred to take like log to the base e. In some textbook it has referred to take log to the base 10. So here I have considered log to the base 10, but you solve according to your professor. So here I am taking x equal to log to the base 10 x, and capital A is given by log to the base 10 a. Okay, so let us understand this with an example. So here the question is being given, fit the least square geometric curve y equal to ax raised to b. Make a note that exponential curve fitting will be given with this form, that is y equal to ax raised to b. Okay, our final equation or the final answer should be represented in the form of this equation. Okay, for the data, and we are given with small x and small y, as we have given with parabola and straight line curve fitting. So let us solve this. So as you can see over here, in the normal equations we need yx, that is capital Y and capital X. So for that, first we'll be writing small x, small y, that is given data we'll be writing here. Then we'll be calculating x, then we'll be calculating capital Y, then xy, and then x square. So first I'll be writing all these data over here: 1, 2, 3, 4, 5, 0 0.5, 2, 2.5, 8, 12.5. So as I have told you, the capital X can be given by log to the base 10 into x. That is, consider here. First I'll be taking log here. I'll be substituting base as 10, and x, in the place of x I'll be substituting this one. So if I substitute 1, I'll be getting 0. Then I have 2 over here, so I'll be substituting 2 over here. So I'll be getting 0 0.3010, 0 0.3010. Likewise, I'll be calculating for 3, I'll be getting 0 0.477. Likewise for 4, I'll be getting 0 0.602, and for 5 we'll be getting 0 0.698. So same goes with this y. For y also we'll be having log to the base 10 into y. So I'll be substituting in the place of x values. Here I'll be substituting with y values, that is log to the base 10 for 0 0.5. We'll be getting it as minus 0 0.3010, minus 0 0.3010. Then for 2 we'll be getting plus 0 0.3010. Likewise for 2.5 we'll be getting 0 0.6532. For 8 we'll be getting 0 0.903. For 12.5 we'll be getting 1.0969. Then we'll be multiplying this x with this y. So multiplying 0 0.3010 with 0, we'll be getting it 0. Multiplying 0 0.3010 and 0 0.3010, we'll be getting 0 0.0906. Multiplying this with this, we'll be getting 0 0.3116. Multiplying this with this, we'll be getting 0 0.5436. And multiplying 0 0.698 with 1.0969, we'll be getting 0 0.7666. Okay, then we'll be squaring this x terms, that is 0 square is 0, square of 0 0.3010 will be getting 0 0.0906. You can check it later on in the calci. Then 0.477 square will be getting 0.2276. Square of 0.602 will be getting it as 0.3624, and square of 0.698 will be getting as 0.4884. Okay, in normal equation we have all summation, right? So we'll be taking the summation of x. The summation of x will be getting by adding all these terms, that is we'll be getting 2.072, and summation of y will be getting 2.6531, and summation of xy will be getting 1.7124, and the last summation of x square will be getting 1.169. okay, I'll be writing them over here. Yes, now let us substitute all these values in equation 1 and 2. First, let me substitute all these values in equation 1. Before that, our n is, here count the values 1, 2, 3, 4, 5. Since we have given with the 5 values, so our n will be equal to 5. Okay, so substituting all these values in equation 1, we'll be getting, first our summation y is 2.6531 equal to, that is our n is 5, so keeping capital A as it is, plus summation x we have got 2.072 and keeping b as it is. So let us call this equation as 3. Then substituting all these values in equation 2, that is summation of xy we had got 1.7124 equal to summation x is 2.072 keeping a as it is, plus summation x square we have 1.169 and keeping b as it is. So let us call this equation as equation 4. So let us solve these equation 3 and 4 in the calculator. So go to mode, select 5, then go to 1, then substitute a value 5, b value 2.072, c value 2.6531. Again the fourth equations, a value 2.072, then b value 1.169, then c value 1.7124. So we'll be getting capital A value equal to minus 0.287, then b value equal to 1.974. okay, we have got the a value and b value to calculate, but we have given with the equation y equal to ax raised to b in the question. Here we have capital A. To find small a, here is our formula. So what is that? A equal to log to the base 10 a. So we already calculated the value of a, that is 0 minus 0.287 equal to log to the base 10 a. okay, so here we have log. If it comes here, it becomes ln. So go to mode, go to here we have 10, shift then 10 raised to, means here in the calci it is known as ln. So 10 raised to minus 0.287 will be getting a value as 0.516. okay, a equal to 0.516. so we have the values of a, b. So then we'll be substituting the a and b value in the question's equation. So y equal to, our a value is 0.516 keeping x as it is, and raised to, that is b, I'll take this as approximately 2. So this is square. So our final answer is y equal to 0.5 x square.